Chapter 3, Applications of Differentiation. 3.1, Extrema on an interval. So the extreme value theorem states if f is continuous on a closed interval ab, then f has both a minimum and a maximum on that interval. So minimum and maximum are basically the highest and the lowest points on a graph. Local extreme values are sometimes called relative extreme values, or the relative minimum, or the relative maximum. When you think of local, I want you to think of nearby. Just like local, right? The word local means that something is within your neighborhood or community, it's nearby. Local extreme values are low and high points, but they are not necessarily the most extreme low and high points. So they're just minimums and maximums. So what I'm going to write is that they are low and high points on the graph of a function, but they're not the extreme. So they are not the lowest value, and they're not the highest value. Global extreme values, or absolute minimum or absolute maximum, think like the word globally. It's more, worldwide rather than within your neighborhood. So anywhere. And everywhere. So these values are the most, and I know this is going to sound weird, the most lowest or the most highest point. So you must be thinking, okay, so there's such a thing as low and high, but then some of them are more low than others, and some of them are more high than others. But yes, that's basically it. Local, nearby, they're low and highs, but they're not the extreme, the most highest and or most lowest. A critical point is where we will find our extreme values. Critical points are anywhere on the slope, anywhere the slope of the function is 0, or the slope is undefined, it doesn't exist. Okay, now f of c is the minimum of f on an interval called I if f of c is less than or equal to f of x for all x in I. So what this means is that we will be able to find our minimum value on an interval as long as our minimum value, which we refer to as f of c, is the smallest out of all the possible x's on that interval. So when I say the smallest, I mean the x isn't itself the smallest, but rather what I get when I plug in the x, my y value, if that value is the smallest value, then it is the minimum. Now the maximum, f of c is the maximum of f on I, which is our interval, if f of c is greater than or equal to f of x for all x in I. So our maximum is going to be located at our y value that is the biggest. But of course, we find our x values to determine what the y value is. And then, so this is a basic definition for minimums and maximums. And critical points are where we're going to find them. Okay, so moving forward, we have here, here's a graph or a picture or diagram explaining the difference between local and absolute, or rather local and global. They do use the phrases interchangeably, so you're going to have to get used to it. It's either local and global or relative and absolute, and sometimes they just combine them. Like here, I got this from a book, and they combined absolute with local. All right, so look at the graph. Okay, it's easy to determine the peaks, the low peaks and the high peaks, right? The peaks and the valleys, rather. So, okay, so this is peak, and this is a peak. And then my valleys, so this is a valley, right? And then this is also a low point, and so is this. Now notice, I have 3 mins and 2 maxes. Now, just looking at the maximums, one of them is higher up than the other. Therefore, that is the difference between local and global, or relative and absolute. This one is the absolute because it is the highest point. Now, this one is still a maximum, but it's only considered a local maximum because it is not the highest point on the graph. It's still a high point, but it is not the highest. And then same for the green points, which are our minimums. One of these points is lower than all the others. It is the lowest, and therefore it is the absolute or global. And then the other two, they are still minimums, therefore they still are taken into consideration, but they're not the most minimum, they're not the absolute. So these are just considered local or relative. Okay, now again, the critical points, or sorry, the critical values, right? So let's see. These are all my x's. These are my values that will allow me to find the point. Because a point is an x and a y, and these are all x's, and in order to find the y, we're going to use our x's to find the y. This section, or rather this chapter, is a lot of graph analysis, but first I have to show you what to analyze. Okay, so example 1, identify each x value at which any absolute extreme value occurs. So absolute, so we're not looking for relative or local, right? We're just looking for absolute, which is global. So the most highest, the most lowest. Okay, so for A, I have my graph, and the highest point is right there, right? B is the location of my absolute max. Absolute max. Now, there was another maximum here, but that is not an absolute. It is a relative or local, so I'm not going to talk about that one, right? Because I was asked to find the absolute. Now, minimums. Here's a minimum as such. This one is 2, right? So I have 2 minimums, but one is lower than the other. So one is relative and one is absolute. So this one is the global one, so I get rid of that one. And so here I have my absolute minimum. Of course, it's difficult to tell you where this is because we don't have any y's. But my absolute my absolute minimum is at C2, whereas my absolute maximum is located at B, right? Let's pretend that's straight. Okay, B. Well, actually, let me talk about the last part of the question here. So explain how your answer is consistent with the extreme value theorem. Now, the extreme value theorem said if f is continuous on a closed interval, then f has both a minimum and a max. If you look at A, it is continuous from A to B, which is a closed interval, and it does, in fact, have an absolute and a min. Oh boy, it does have a max and a min. All right, so B, let's go ahead and take care of the explain part while we're at it. It is continuous on a closed interval, so therefore it does have a highest and lowest point, and they are easily seen. Here is the highest point, and as far as lowest, there are 2 valleys, right? But one is a lot further down than the other. So at B is where my absolute minimum is. Okay, and that's it. So this is my min, this is my max. Critical numbers. A critical number, right, is going to help us figure out where our mins and maxes are. If f has a relative minimum or relative maximum at x equals c, then c is a critical number of f. Now, let's minimum, relative, and relative maximum. Notice how I did not say absolute. And if we go back real quick to the picture, notice how my absolute mins were also called local, and my absolute max was also called local. So notice how my absolutes were also called local or relative. Okay, so all of them are relative, but only one of them is the absolute. So that means that our critical values get us all of the mins and maxes. The critical numbers will find us all of the mins and maxes. It is up to us to figure out which one is the absolute. Okay, example 2, find the critical points. So this is when we have to start paying attention to words. We can use a technique to find our critical number, which is the x. But then we are asked to find sometimes the critical point, which means an x and y. Okay, it is really important that you do read. So a point is an x and a y. So if we're going to use a technique to find x, and then it is up to you to figure out what y is. Sometimes you're asked to find a critical value, or the absolute maximum, the value of it, or the minimum, the value of it. They're asking you for y. Okay, so sometimes you're asked for x, sometimes you're asked for y, and sometimes you're asked for x and y. Okay, so critical point. Now let's go. You might want to revise. What is the critical point? The critical point is anywhere the slope of the function is 0, or the slope is undefined and doesn't exist. Okay, so the slope is 0. Let's go with that. So here I have a function, and I can very easily make its slope equal 0 by finding the derivative. Derivative is slope. So if I find the derivative of this function, I get 6x minus 24. If I take this derivative, and I set it equal to 0, I can then figure out what the x value is, and that is my critical number. So 6x equals 24, divide both sides by x. So this is my critical number. So now my job is to figure out what y is. So then you take the original function and you plug in your critical number, which is an x, to figure out what y is. So 3 times 4 squared minus 24 times 4 minus 1. And then you do the math, and it is negative 49. So the critical point, let's see, there is a critical point at 4, negative 49. Now notice, I didn't talk about it, but it's kind of important that my x actually be in this interval right here. And 4 is in between negative 1 and 5. Right? So since that is the case, then I can go ahead and do this. Okay? If my interval had been, oh, I don't know, negative 1 to 3, then I'd be like, oh, no critical points in between negative 1 and 3. Okay? So my critical point is 4, -49. Example 3, find the critical point of f of x on -1 to 2. Okay, so again, closed interval, right? Gotta make sure that whatever value I get is actually in between -1 and 2. I'm going to find the x value, my critical number, and then I'm going to use my critical number to figure out what y is. Okay, so I'm going to find my critical value by setting this function, this derivative, this function's derivative equal to 0. So first I got to find the derivative. So 3 times 6 is 18x squared minus 24x cubed. So you take that and you set it equal to 0 because ideally the critical value is anywhere that the slope is 0 or non-existent. But this is a polynomial, and polynomials are continuous and therefore differentiable. So there is no place where it's non-existent. Okay, so let's see, what do they have in common? They have the number 6 and x squared in common. So 3 minus 4x. And then do or use, whatever you want to call it, the zero product property. So 6x squared equals 0, which means x is 0. And then 3 minus 4x equals 0, which means x equals 3/4. Okay, so these are my critical values, or critical numbers, sorry. And are they both in my interval? Yes, they are. 0 and 3/4. We're good. Okay, so now we're going to go ahead and plug these in to my function, the original function, to figure out what y is. So f of 0 and f of 3/4. So 0 minus 0 plus 5. And then 3/4, not a pretty number. Not a pretty number to have to plug in. Not impossible either. This is probably going to be a calculator one. So plug in and you get 9.430, and that is rounded to 3 decimal places. So then my critical points are at 0.5 and 3/4 and 9.430. Right. Example 4, or sorry, guidelines for finding extrema on a closed interval. So basically, this is what I've been doing. Somewhat, right? You find the critical numbers, which I did by deriving, setting it equal to 0. And then you evaluate the function at each critical number, okay? That's when you plug in the critical number into the function to get your y. Now, what I haven't done is this part and this part. Well, we didn't have to write that part. Before, it's not what we were doing. But 1 and 2 is basically what we just did. Now I'm going to show you how you're actually going to determine whether it's a minimum or a maximum. So the guidelines are basically what we've been doing. Do the critical numbers, plug them in, get your y. But then, to actually figure out which is the min and the max, what you're going to do is you're going to also plug in the endpoints. So your interval is when comes into place here. Your interval, you got to plug in those x's to see what y would be. And then from all of your answers, you're going to determine, okay, so which one is the smallest y, which one's the biggest y, and that's how you determine your min and your max. Okay, so now we are finding extrema, which is just plural for the most extreme points. And so they're never going to really say, I don't think so anyway, they're not going to say, go ahead and find the min and the max. I think most of the time they just tell you find extrema. I could be wrong. But extrema means both. So don't just find the min and be like, I'm done. Or find the max and I'm done. Because that's not right. So find the extrema. So again, just what we've been doing. I'm going to figure out what the derivative is. 12x cubed minus 12x squared. Okay, now I'm going to take the derivative and set it equal to 0 to figure out what my critical numbers are. So these terms have 12x squared in common. So x minus 1. Zero product property, I get x equals 0, and I get x equals 1. So here are my critical values, or critical numbers. Now, to figure out my most min and most max, right, I also have to check the endpoints. Because, for example, real quick sketch here. You don't have to draw this. What if my function looks like this? And what I just got was 0 and 1, right? Or, I mean, this is a bad example, but because I made a straight line. But whatever. 0 and 1. Well, guess what? This is the minimum and this is the maximum. I don't know. Let's add some curves here, people. Ha! There we go. Perfect. So what I just got was this max here and this min here, but those are local, and this one is lower, right? That's the lower min, and this one's the higher max. So you have to check your endpoints, because they could be the min and max. Alright, so back to what I was doing. So we found our critical numbers, and so now normally, right, what I had done before was we would plug these in. And you are going to plug them in, but you're also going to plug in -1 and -2. So plug in -1, plug in 0, which is what we just found, plug in the 1 that we just found, right? And now we're going to plug in 2. You don't have to necessarily do it in numerical order, but I just want to make sure. These are the endpoints and these are in between, okay? So you would plug all of these in to the original equation. And then you get what you get. So let's see, plug in -1 and we have 3 plus 4, which is 7. Plug in 0, we get 0. Plug in 1 and we get 3 minus 4, which is -1. And then plug in 2 and we get 48 minus 32, and that is 16. Alright, folks. So you look at all 4 y's and figure out which one is the biggest. 16 is the biggest. And which one is the smallest? And that would be -1. So then, our maximum is located at -1. Well, rather, x equals 1, and the value is -1. And then our, what did I say? Maximum? I already forgot what I said. Okay, our minimum is located at 1, -1, and our maximum is located at 216. So there you go. Here's my answer. F of x has a maximum of f2 equals 16 and a minimum at f1 equals -1. Points are okay too. Okay, example 5. So this one, let's just go ahead and use the calculator, okay, for the trigonometry, because I don't want the video to be too long. Find the extreme of f of x equals 2 sine x equals cosine 2x on the interval from 0 to 2 pi. Okay, derive. So the derivative is 2 cosine x minus 2 cosine becomes sine 2x, and I got this 2, sorry, negative sign, which makes this positive, and I got this 2 because the derivative of 2x is 2. Okay, you're going to supposed to set this equal to 0. Now, this right here has an identity, which is very commonly used on AP questions. I'm not saying every single one of them is going to have it, but it will show up. So I can make this equation more manageable by changing sine 2x to what it equals. which is 2 sine x cosine x. Okay, now, set this equal to 0. In order to find the x, I have to do the same thing I've been doing, which is factoring, basically. Now, there are things that can be factored. For example, these 2's can both be factored out. And there's a cosine in each term that I can get rid of. So, 2 cosine x has been factored out. And then what's left is 1, right? This part here becomes 1, the whole thing. Okay, I need to finish that gap bit. Okay, and then what's left on the other side here is plus, and then 2 sine x. Take the zero product property, and so 2 cosine x equals 0. So where is the x coordinate equal to 0, or what angle? And there's only 2 places, right? So there's only 2 places that my x coordinate equals 0, and that is at pi over 2 and 3 pi over 2. Okay, now over here, 1 plus 2 sine x equals 0. Subtract the 1. 2 sine x equals negative 1. Divide by 2, sine x equals negative 1 half. You can't do this on the calculator. You can do the sine inverse, or arc sine, whichever one your calculator might say. And basically, at what angle is my y coordinate negative 1 half? Now, positive 1 half, right? My y coordinate is a positive 1 half at 30 degrees, or pi over 6. Now, for it to be negative, it means that it has to be in the third or fourth quadrant. And in the third quadrant, pi over 6 is actually 7 pi over 6. And in the fourth quadrant is 11 pi over 6. Now, see, your calculator won't tell you this, as far as I know, unless there's a brand new handy dandy calculator out there that tells you all of the values. Okay, now, I have all of my critical numbers. I've got a bunch of them. I've got 4. So the next step would be to take all of them and plug them in, plus my endpoints. So f of 0 all the way to f of 2 pi. I'm going to plug all of this in. Oops. Okay. And then these 4. So f of pi over 2, f of 7 pi over 6, f of 3 pi over 2, and then f of 11 pi over 6. Okay, now I do have all the values, so I'm just going to tell you what they are. So negative 1, 3, negative 3 halves, negative 1, negative 3 halves, and then negative 1 again. Because 0 and 2 pi are basically the same thing, right? Right, people? Alrighty, so let's looky with our eyeballs. Which one's the lowest and which one's the highest? So, the highest y value is here, so that's where my maximum is. And the lowest is, oh, there's 2 of them. Negative 3 halves, right? Because it's negative 1.5, and that is lower than negative 1. So, just to save time, I'm going to be like, this is my max. And we have 2 mins. We have a tie, ladies and gentlemen. Because they're the same. Right? And that's it. Homework. Watch the next video.